Okay, we are in section 922, which we are going to look at more one variable inequalities today. If you scan through your notes page, you only see one type of variable in the entire inequality mathematical statement. Okay, so I really think that a lot of you guys can probably put me on pause and try almost the whole note sheet yourself, and then kind of watch my work go through and correct yourself. That might be a better way of learning, as to just instead of robotically copying down what I say. So I challenge you to try these before you just watch me go through every single problem. All right, so it says in lesson 921, you learned how to solve inequalities with one variable. Let me get my pen. One variable. Okay, today we are going to focus on special inequalities and learn how you can use inequalities to solve application problems. That will be on the back of your note sheet. So 56 says, let's review what we did on the last lesson by solving the inequalities below. Now, I said last notes sheet that we need to always represent our solution as an inequality and also on a number line. So your solution always will have kind of two parts to it. Okay, now your note sheet looks slightly different than mine. I just need more room to write, but it is the same problems. Okay, so A says x minus 7 is less than negative 2. Now I'm going to go through these and treat them like equations, but I'm going to keep the inequality symbol so that that allows us to have our final answer without using test points. Okay, so we need to remember the key idea from yesterday was our boundary point. So in order to find the boundary point of the graph or of the inequality, we must treat it like an equation. So we're going to use our solving skills. So the first thing I'm going to do here is I'm going to add 7 to both sides. Okay, now I keep the symbol of the inequality the same unless I am dividing or multiplying by a negative, which adding 7 doesn't fall into that category. So I keep my less than. Negative 2 plus 7 is 5, and like that, I'm done. That is my inequality. Okay, all numbers that are less than 5 will make the original statement true. So for example, give me a number less than 5. Well, 0 is less than 5. So 0 minus 7 better be less than negative 2. What's 0 minus 7? That's negative 7. Do you agree with me that negative 7 is less than negative 2? Yes, it works. Okay. So just kind of showing you how it all relates. So now we have to graph on a number line. So the first thing I'm going to do is you don't have to sit there and make tick marks for every single whole number. And I know that my reference point, my boundary point is 5, and it's not or equal to, so I keep my open circle. And then it's all numbers that are less than. So I'm going to shade everything behind 5. And again, like we pointed out yesterday, this inequality symbol, the gator mouth can kind of look like the arrow pointing in the direction you need to shade, just so long as that X is on the left side. It has to be, or else it's going to be opposite. Okay, moving along to the next problem. I have 3m plus 2 is less than or equal to 8m minus 8. So just like equations, we need to work to get our m's to one side and our units to the other side. I don't like my m's to be negative, so I'm going to choose to subtract 3m from both sides. That is not dividing by a negative, so my inequality symbol will stay the same. So I have 2 is less than or equal to 5m minus 8. Now, because my m's are on the right-hand side, I'm going to move my units to the other side. So I'm going to add 8. So then I get 10 is less than or equal to 5m. Now, to get m by itself, I divide by 5. Now, 5 is not negative, so I do not change the inequality symbol. So I have 2 is less than or equal to m. Okay, now if I leave it this way, I might be tempted to shade in this direction. So I always encourage, before you circle your final answer, to rewrite it so that the variable comes first. So please do that. We have m. The big mouth stays facing toward the m, and then I am comparing it to 2. So m is greater than or equal to 2 is the same thing as 2 is less than or equal to m, but it just makes more sense when we write it with the variable coming first. Okay, so now let's go ahead and go to the graph. We have a 2. I'm going to put my -2. And because we know kind of the shortcuts and the rules for solving inequalities analytically, I'll say, without using a test point, I can put my, is it going to be open or closed? It needs to be closed because it's or equal to, and it's all numbers that are larger. The open mouth is towards our variable, so we are going to shade in that larger direction. But if you ever doubt yourself, you can always check using the original equation. So let's check using a point in the interval. So I think 4 sits here, right? So we are going to ask with some question marks. Let's plug it into the original before we changed anything. 3 times 4 plus 2, is that going to be less than or equal to 8 times 4 minus 8? Okay, well, 3 times 4 is 12. 12 plus 2 is 14. Is 14 less than or equal to 32 minus 8 is 24? Yes, it is. So we can be pretty certain our answer is correct because the number we checked is true and it falls in the shaded region. Okay, so now let's move on to this next one. We have 2/3 p minus 2 is greater than -4. Okay, so we have adding 2 is our first step. Treat it like an equation. So 2/3 p is greater than -2. Now this is interesting, okay, because you could say then divide both sides by 2/3, but I'm sitting here and maybe you don't have a calculator right next to you. So this is a great opportunity for me to do like a sub lesson and say that when you have to divide by a fraction, that's the same thing as multiplying by the reciprocal of the fraction. The reciprocal is what happens when you flip the fraction. Because let's think about it. If I take 2/3 times 3/2 and multiply straight across the top and straight across the bottom, I get 6/6, which is 1. So that leaves me with p. But what I do to one side, I have to do to the other side. So I have to multiply this side by 3/2. Now, did I multiply by a negative? No, so I keep my symbol. And then I multiply straight across the top and the bottom, so -2 times 3 is -6. And then 1 times 2, because it's a whole number, so the denominator is 1, is 2. So I definitely want to do that quick division and say that I have -3. Now you might be asking, okay, well, there was a negative involved right here. I was multiplying by a negative. But if you look back at your notes, it's what we're multiplying both sides by. So because that's not negative, then you're not going to flip your sign. Okay, so this is the inequality that represents the solutions that will make the original problem true. So I'm going to go ahead and place my numbers. I see that it's going to be an open circle and it says all numbers that are greater than. I love when 0 falls into the shaded region because then I can quickly check 0 by doing is 2/3 times 0 minus 2, is that question mark, is that greater than -4? So again, I am checking right now. So 2/3 times 0 is 0. So is -2 greater than -4? You might be tricked by that, but the answer is yes, because the less negative a number is, the greater it's going to be considered when compared to other negatives. Okay. Got 3 more problems. Hopefully you're trying these on your own and then going from there. Okay, so now we have distributive. So let's go ahead and expand first. So we have 2 minus 3x plus 3, because we got to distribute in, is greater than or equal to x minus 7. Combine my like terms on the left side. So 2 plus 3 is 5 minus 3x is greater than or equal to x minus 7. So I want to move my -3x over, so I'm going to add 3x to both sides. So I have 5 is greater than or equal to 4x minus 7. Now I'm going to go ahead and add that 7 over. and I'm going to get 12 is greater than or equal to 4x. Divide both sides by 4. So I get 3 is greater than or equal to x, but remember what I said a few problems ago, we want to rewrite it so that we look at x is less than or equal to 3. The small mouth still remains on the x, but this makes a lot more sense in the way we've been doing problems. So now to put it on the number line, okay, we're sitting at a closed circle on 3 because it's or equal to, and it says x is all numbers that are smaller. So I am shading also in the direction that the inequality sign is pointing because I did choose to turn it around so x was in front. So there is our solution set. Again, 0's in our solution set, so if we plug it back in and do the checking, it will work. All right, on E, it looks messy, but really all we have to do is clean things up by combining our like terms. So we have 9k minus 3 is less than or equal to 9k minus 3. That's really interesting. It seems like we have the same thing on both sides, but what if we didn't notice that? Let's see what happens. Okay, so if I add 3 to both sides, then negative 3 plus 3 is 0. Negative 3 plus 3 is 0. So now I have 9k is less than or equal to 9k. And you might say, let's move all of the k's to one side. So let's subtract 9k. Let's subtract 9k. So 9k minus 9k is 0 completely. And then I haven't divided by a negative. 9k minus 9k is 0. So let me ask you, is 0 less than or equal to 0? The answer is yes, because that or equal to saves us. So this is a special case. What numbers are going to make the inequality true? All real numbers will make the inequality true. So x can be any real number. So I'm going to go ahead and shade the entire number line and shade both arrows and think about, okay, it makes sense when you look at 9k minus 3 is less than or equal to 9k minus 3. Pick any number. You're going to plug it into the left side and you're going to, let's do 0. So 9 times 0 minus 3 is 0, or is negative 3, and then 9 times 0 minus 3 is negative 3. Is negative 3 less than or equal to negative 3? Yes. Okay, so again, just stressing that that or equal to saves us. Because now if we go to this last example problem here, we see that we have 3y plus 1 is less than 3y plus 1. Okay, if you notice that both sides are equal, okay, if you just simply say, okay, let's let y equal 1. Let y equal 1. So you can kind of see what's going on. So we have 3 times 1 plus 1. Is that less than 3 times 1 plus 1? Well, we have 3 times 1 is 3, so 4. Is that less than 4? A number is not less than itself. Okay, so we could carry through the process and we could subtract 1 from both sides and subtract 3y, and what are we going to get? We're going to get 0 is less than 0. And this is just simply not true. It's never going to be true when you have a number being less than itself. So what are the solutions going to be? This is going to be a no solution problem, inequality. There is no value of x that will make that inequality true. So what do we do on the number line? We do nothing. We don't shade it at all. Okay? So hopefully you're feeling more confident now with one variable inequalities, because you know what's going to come next is going to be 2 variable inequalities in the lessons to come. Okay, but now to kind of summarize what we've been learning and show you how it relates to first semester content of linear equations, let's read 58. It says, in 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of friendship. Similarly, the nation of Cameroon plans to give flowering sada trees to other countries this year. When asked how to decide which sada trees make good gifts, Cameroon's chief arborist explained, "We plant sada trees when they are 6 centimeters tall." Plant seems like a key word. And they grow 9 centimeters every year. The trees will only flower when they are taller than 150 centimeters. Okay, taller than implies not equal to. Taller than implies what? Greater than. So that's where the inequality is going to come into play in this problem. So it says, it is very important that the Cameroon trees give flowers this year. It would be considered an insult to receive a tree that did not bloom in their culture. Okay, so luckily Cameroon has many groves of sada trees from which they select its gifts. How old must the trees be in order so that they will flower within the year? Okay, so we need to think about, is inequality or equation going to be more appropriate for this situation? Well, certainly inequality, because whenever you see kind of the word than, that's a good clue that it's going to be inequality. So the key word in this one was taller than. So we don't just want the trees to be 150 centimeters. If we can find trees that are greater than 150 centimeters, so 151, 152, 153, all of those trees will work. So there are going to be many heights that will work. Okay. So, let's see what they're going to have us do. Write and solve a mathematical sentence. Now, they're saying that because they don't want to say equation, because we just said that an inequality is what we need. So we're going to write a mathematical sentence that's going to help us determine how old the trees can be so that they flower this year. Okay, now, I had mentioned before, this is a linear situation. Remember, linear is y equals mx plus b. This is great review. Okay, m represents growth, b represents starting point. I think if we go back up to our story problem here, we can find the word grow, and we can find the word that implies starting point, which is plant. So if we think about describing the growth of the tree, okay, hopefully you are agreeing with me that, let me pull up my sheet in front of me so I don't have to keep scrolling, that we're going to start at 6 centimeters, and each year they are going to grow 9 centimeters, so let's let x represent the number of years. And we want to compare this height of the tree to being 150 centimeters, but we want the height of the tree to be what compared to 150? We want the height to be greater than 150. So this is the inequality. Okay, so at this point, let's go ahead and solve it like we did on the front of the note sheet. So to solve this inequality right here, okay, we want to get x by itself, so we are going to subtract 6, so we have 9x is less than 150 minus 6 is 144. And then we're going to go ahead and divide by 9 on each side, and we have x is greater than 16. So what does this mean? It means that the tree must be older than 16 years. It can't be 16 years because most likely that will make it exactly 150 centimeters, but we need it to be beyond. Okay, so that is the age of the tree. Finally, though, it says, the arborist added, I almost forgot to tell you that when the trees become very old, they stop flowering. Make sure you choose trees that are no more than. There's another word, like we kind of learn our vocab for making equations and inequalities, no more than 240 centimeters tall. So we want to figure out, okay, then how old is going to make it too old? So we need to write another inequality, but the tree isn't changing in terms of the growth. So this still represents the height of the tree. So if it was 1 year old, you'd do 6 plus 9 times 1. If it was 5 years old, you'd do 6 plus 9 times 5. But we also need this height of the tree to be less than 240 centimeters. Okay? So this is kind of the upper limit. So now to solve this, we're going to do the same thing by adding 6, and we get 9x is less than 246. Divide by 9, and we get x is less than 26 years. So this is kind of like, again, that the domain template that we talked about and saw yesterday too. We have an interval. Okay, if we're looking at a number line and we're looking at age of the tree, we have 0, and then we have like 10, 20, 30. We see that, okay, the youngest the tree can be, it has to be older than 16. So if I change my color, we have 16 occurring here, but we have to put an open dot. And then we have 26 occurring here, and we have to put an open dot. So this is the interval of the lifespan of the tree that will produce the flowers. So how can we write that? We can write that as a two-part inequality where we put our low amount at the front and we put our high amount at the back. So this says the tree must be between 16 and 26 years in order to provide flowers. Okay, so I really do like this problem because it ties in our knowledge of linear functions, which we became experts on first quarter. Great job. Keep working on those one variable inequalities because two variables are soon to come, and keep letting me know if you have questions. Keep up the good work, and we'll talk to you next lesson.